Why does it freeze instantaneously?
Yasu-san, would you measure the temperature of this unusual water?
With this?
Yes, use this thermometer. Well, it's negative, below 0 Celsius.
Lower than the freezing point.
Minus 1.6 degrees Celsius.
Shouldn't it be ice at that temperature?
Yes, why hasn't it frozen?
Water that is liquid below the freezing point is called supercooled water. Water can exist as a liquid below its freezing point, but it's in a very unstable condition. Now, any kind of impact or disturbance will cause it to freeze and become stable. This is often seen in nature with cloud droplets in the upper atmosphere, supercooled below water's freezing point.
Oh, really?
In aerospace engineering, this is treated as a danger to aviation.
Research has begun that looks at the problem. The goal is to understand how to counteract the icing that occurs on aircraft due to supercooling. Aircraft fly high up where temperatures are low. The clouds and water vapor contain supercooled water that instantly freezes into ice when it comes in contact with the wings. A tragic example of what can happen occurred in 2009 during the cold of winter. In that case, a passenger aircraft went down in Buffalo, New York. The general consensus is that it was ice on the wings that reduced the aircraft's lift and led to the accident. So supercooling is a very important issue.
Clearly it is.
A phenomenon that is very beautiful, but at the same time potentially dangerous.
Supercooled water has other unusual properties. Look at this. We shot thermographic footage at night in Zao. The upwind side of the soft rime looks yellow. Now, that's the part of the tree that exhibits the shrimp tail effect. It's generating heat.
Wow, you'd expect the upwind side to be colder.
Next, we used an infrared camera to capture the freezing of supercooled water in the lab. Before it freezes, it is green, indicating a temperature of minus 3 degrees Celsius. As it begins to freeze, the color changes to red and white. The temperature rises 3 degrees. When supercooled water freezes, it releases heat. Then at 0 degrees, it turns to ice. It's a weird property of water.
Why does water generate heat when it freezes?
In liquid water, the molecules are moving vigorously and have a lot of kinetic energy. In ice, the water molecules don't move much, so the kinetic energy in ice is quite low. When water freezes, it gives up the kinetic energy. The energy given up is the so-called latent heat of freezing. So the supercooled water we saw earlier was at minus 3 degrees. After it released heat, the temperature rose to 0 degrees and it froze. Supercooled water is actually found everywhere in nature, throughout the world. But the degree to which soft rime ice forms is only found in Japan, in places such as Zao.
What's the secret of Zao?
Let's take a closer look at the process that's responsible.
West of the Zao Range is the Asahi Range. Supercooled water is caught up into the wind over the Asahi Range. In northeastern Japan, seasonal winds blow from the northwest during the winter. The Asahi Range and the Zao Range are directly in the path of these winds. As the seasonal winds cross the Sea of Japan, they suck up large amounts of moisture. The water vapor gradually cools until it becomes supercooled droplets. The droplets first hit the Asahi Range, but soft rime doesn't form there. The droplets are too numerous and instead fall as snow. As a result, a reduced quantity of supercooled water droplets is carried by the wind. These are transported to the Zao Range, where they form soft rime ice. This phenomenon occurs because the Zao and Asahi ranges are of roughly the same altitude. If the Asahi range was a little taller, too many supercooled water droplets would be lost there to form soft rime. If the Asahi range was a little lower, too many supercooled droplets would continue past it and become heavy snowfalls on the Zao range, swamping the soft rime. It is these two parallel ranges, both around 1,800 meters in elevation, that produce the soft rime.
So water's unique properties combine with just the right geography to create those trees coated in soft rime ice.
I lived for a while in the American Midwest. The winters are cold. During my time there, I noticed that ice sometimes formed on the trees and cars. But this large-scale soft rime ice phenomenon seems unique to northern Japan.
Next, let's turn to a wonder of water created by another unique geographic setting. Ehime is a prefecture on Japan's smallest main island of Shikoku. Here, a mist formed of tiny water droplets suspended in the air creates a remarkable spectacle.
In western Ehime Prefecture, a river called the Hijikawa enters the Seto Inland Sea. On winter mornings, a phenomenon called a Hijikawa mist storm can occur.
The sky turns white.
It's like thick clouds of steam over the river.
The Ozu Basin upstream along the Hijikawa is known for its mists. These mists flow down from the basin to the sea along the river valley. This phenomenon has been compared to a white dragon. On clear winter nights, radiant cooling causes the temperature of the basin to dip below freezing point. This causes water vapor to condense into small droplets, raising a mist. Sometime past 2 a.m., the mist suddenly thickens and envelops the basin. When dawn comes, mist fills the basin to the brim. The layer of mist is around 300 meters thick. From a high vantage point, it looks like an ocean of clouds. The basin has an outlet to the Hijikawa River Valley. The mist flows down along the river valley. A white dragon twisting downstream. This time-lapse footage shows a huge bank of mist tumbling violently down the river valley. This is called a Hijikawa mist storm. It is the only